Welcome to this session.
This session provides a practical guide for deploying Springboot applications on Open Liberty, offering tips and best practices to enhance performance and leverage Open Liberty's enterprise-grade features for optimal application development. We have with us two speakers, both software developers at IBM, who bring a wealth of experience to the stage. Gautam, with 7 years in the industry, is a software developer at IBM Software Labs, where he focuses on traditional WebSphere application server development. Additionally, Gautam actively contributes to the enhancement and maintenance of Open Liberty Server. Joining him is Alexander, a seasoned back-end Java developer, with 9 years of experience in implementing and optimizing robust back-end systems. With expertise in Java, Spring Boot, Hibernate, and various database technologies, he excels in designing scalable and high-performance applications to meet complex business requirements. Together, they'll explore how Spring Boot and Liberty combine simplicity with flexibility. Let's all welcome to our digital stage, Mr. Gautam Krishnan and Mr. Alexander Abraham.
Yeah, hi everyone. My name is Alexander and I'm part of the WebSphere development team and I'm joined by Gautam here today. Hey Gautam, how are you?
Hey, all.
Yeah, so let me go ahead and share my screen first. And I do hope the screen is visible, right, everyone? I take that as an S. Okay, so we'll be taking a session on like Spring Boot with Open Liberty. And we all do know like what a Spring Boot is and what are the benefits that it offers to us. But for someone who is actually new to this, just a quick intro to that part. Like Spring Boot is a really cool framework that has been developed on top of the Spring framework, which simplifies the development and standalone production-ready applications. Now, it does offers a whole bunch of features like embedded servers, easy dependency management, which kind of helps developers to quickly set up and run their applications. Now, it removes a whole bunch of boilerplate codes, helping the developers to reduce the code and avoid a whole bunch of config changes, making it an ideal for microservices and RESTful APIs. So it does have an embedded Tomcat server in it, which helps the developers to run the applications as the standalone Java application without any complex setups. It also includes certain production-ready features like health checks, metrics, and externalized configuration options, something like that. So in a nutshell, the Spring Boot accelerates the development process, enabling the developers to focus on writing business logic rather than wrestling with configurations, making it an ideal choice for the enterprise applications and microservice architecture. By default, we do have something called a Tomcat server running in these Spring Boot projects, but we also have an option for selecting other application servers. And as part of this session, we will look into like one such application server, that is the Open Liberty, and look into like why it is ideal and what are the benefits that it offers. And if possible, like we'll go into kind of a small demo, like with some of the features which Open Liberty offers to us. Okay, so that was all about like what we are going to do in this session and a small intro on like what a Spring Boot is. Like before we actually kind of move into Open Liberty, like it will be good to have a kind of a brief introduction, like how we came up to the point of Open Liberty, a kind of a walk through the history part. So we do have something called a traditional WebSphere or TWAS, which is kind of a brand name for IBM. And the traditional WebSphere or TWAS, the Liberty and Open Liberty are all related to IBM's WebSphere product family, which provides software for building, deploying, and managing Java-based enterprise applications. Now, TWAS is a full-featured Java Enterprise Edition application server that provides a runtime environment for Java applications. Now, it is kind of a heavyweight, and its heavyweight nature is due to the comprehensive array of features and functionalities that has been developed over past 2 decades to cater the complex enterprise level applications. Now, whether it's a database integration or some specific security configurations, TWAS offers adaptable solutions for that. However, with the changing times and evolving paradigms, the trend is towards the lightweight and agile framework. And in today's cloud native landscape, there's a demand for the faster execution with minimal memory footprint and latency. Now, as TWAS transitions into a cloud native realm, its natural progression involves becoming smaller and more agile while preserving its core values. On the other hand, the WebSphere Liberty is actually distinguished by its lightweight runtime kernel, which offers a high degree of flexibility. Now, it integrates various functionalities from the WebSphere application server as independently installable features. Now, its modular approach allows you to customize the runtime environment specifically to meet the unique requirements of your application. Now, as we shift towards the cloud computing and microservice architecture, the way we build and deploy applications is kind of evolving. And WebSphere Liberty's ability to be tailored to exact the application needs align with all these modern architecture trends. Its lightweight nature not only facilitates this customization, but also makes Liberty an excellent choice for deployment in containerized environments. Now, the efficiency and scalability of Liberty in containers make it well suited for the dynamic scaling and adapting to the demands of the contemporary applications. In the last decade, there has been a substantial rise in the demand for the open source technologies, which prompted to the transition of the WebSphere Liberty to an open source model under the name of Open Liberty. And this shift reflects to the broader trend towards the open source solution and their growing popularity within the industry. The WebSphere Liberty encompasses everything that is available in the Open Liberty, but it also offers certain additional features which are specifically designed to ease the modernization of existing enterprise applications. Now, Open Liberty is an open application framework that is meticulously crafted for the cloud environments, and its design emphasizes being compact and lightweight, making it particularly well suited for the contemporary cloud native application development. Open Liberty fully supports the microprofile and Jakarta EE APIs, ensuring the comprehensive functionality for building modern applications. Its composable architecture allows the developers to select and use only those features that they need, which helps to maintain a lean and efficient system. And this modularity is especially beneficial for the microservices where efficiency and scalability are kind of crucial. Additionally, Open Liberty is designed to for the seamless deployment across all the major cloud platforms, which includes Docker, Kubernetes, and Cloud Foundry. And this flexibility ensures that the applications can be easily scaled and managed in diverse cloud environments, enhancing their adaptability and performance in today's dynamic technology landscape. Now, we will start by exploring the concept of something called operational uniformity, and then we will delve into the idea of the capacity gains and all. And for this, I'll ask Gautam to take over. Over to you, Gautam.
Hey, thanks, Alex. So to set the stage, I want to discuss why capacity gains are important. Moving beyond the basic notion that more capacity is inherently good, it's crucial to recognize how the rise of cloud computing has transformed our understanding of applications and influenced our decision-making processes. So this shift has actually redefined where trade-off exists, prompting us to consider not just capacity, but how it aligns with operational efficiency, scalability, and overall strategic goals. So cloud computing fundamentally translates to financial implications, right? The more resource you utilize, be it increased CPU power, additional RAM, or expanded disk space, the higher your operational cost will be. This direct relationship between resource consumption and expenses means that efficiency gains are crucial. So achieving better performance, minimizing resource footprints, reducing memory usage, or enhancing density can lead to substantial cost savings in real world. Consequently, understanding capacity gain is not just a technical consideration, it can significantly reshape your perspective on application management and optimization. So by prioritizing efficiency, organizations can better align the resource usage with their financial goals, ultimately transforming how they design, deploy, and scale applications in the cloud. We recognize that there are inherent trade-offs involved in addressing these considerations. So if you look at the picture itself, right, optimizing performance, you often find yourself balancing various factors such as CPU utilization, resource footprint, startup times, and other critical metrics. There isn't a singular right answer. The optimal approach truly depends on the specific workloads you are managing and the goals you aim to achieve. IBM has a strong legacy of prioritizing performance in solutions, and we want to highlight some of the significant performance benefits you can gain by utilizing technologies like Liberty and OpenGNI. Both of those are actually open source now, but backed by IBM. And these tools are designed to streamline resource management and enhance application efficiency, ultimately making the trade-off less burdensome. By leveraging these technologies, organizations can navigate the complexities of performance and optimization more effectively, ensuring that their application not only meet current demands but are also scalable for future needs. Yeah, please go to the next slide, Alex.
Yeah, okay. Thanks, Gaurav. Okay, so shared class cache. So what is actually the shared class cache and how does it impact the application performance? Now, we do understand that minimizing the startup time can lead to a significant cost savings, and the shared class cache technology is a key player in achieving this when deploying with OpenLiberty. Essentially, it's a feature of OpenJ9 and it optimizes the way the classes are loaded and reused. To break it down, uh, when you load a class for your application, or in this case, the OpenJ9 itself, the class loaders can store that class in a shared cache in an optimized format. Now, this mechanism allows the Java virtual machine to quickly access the class from the memory on subsequent starts, rather than having it to retrieve it from the original source each time. So typically when a class is loaded, the class loader must locate the bytecode, which is often stored in a jar file. And it then reads the bytecode into a byte array before passing it to a JVM. The JVM subsequently performs various tasks, such as validating the class and allocating the memory before it can actually execute any of those code. Now, with shared class cache, uh, this entire process is actually kind of streamlined. The classes are stored in a manner that allows for the rapid retrieval, significantly cutting down the time it takes to start an application. Now, furthermore, if you kind of profile your application or run it multiple times, the shared class cache can improve with each iteration. And this is because the just-in-time compilation can kick in, allowing some of the compiled code to be stored as ahead of time compiled code. And as a result, less JIT compilation is required during the application restarts. Now, by leveraging this technology, you can expect a notable improvements in the startup times, leading to a more efficient application experience overall. Now, this not only enhances the performance, but also contributes to a better resource utilization, ultimately benefiting your operation cost and efficiency. Now, in summary, the shared class cache is a powerful tool for optimizing the application performance in cloud environments. With OpenJ9, we enhance the process by preloading certain data into memory as part of our startup sequence. Specifically, we can include this information in our container image as part of the Docker files. Now, this means that when a container is launched, it already has all the necessary cache data available, which was not generated during the runtime, but instead it was created during the Docker build process. As a result, everything the container needs is actually kind of pre-populated, ensuring a faster and more efficient startup. The enterprise images for OpenLiberty and WebSphere Liberty are built on what we call as SEMR images, which utilize OpenJ9. And these images come with a pre-prime cache specifically for the base JVM, meaning there is already a certain amount of cache data available. But this ensures that when you load components from the JVM, they are already prepared at the most lower level, and this foundational cache remains unchanged even if unchanged unless your JVM version is kind of modified out there. So in which case you obviously will need to rebuild and all the layers in the Docker and everything. And additionally, our server classes and class loaders are responsible for loading the server image and are designed to effectively store the data in the shared class cache. On top of that, your application classes are also getting stored in the same cache that resides on your image. Now, there are other caches that we have in Liberty and that are not just shared class cache, but the stuffs um, that has information about your application, stuffs like annotation scanning. And we can read all those stuff so that when we load it, when we load your application, it can be loaded quickly without having to rescan your annotations and various other metadata that is contained within your application. Now, by leveraging this caching strategy, we not only accelerate the class loading times, but also reduce the amount of JIT compilation which is required during the startup. So as much of this information, all this information are getting cached, they can be loaded quickly, ultimately enhancing the performance and streamline the application initialization. So what are the requirements for utilizing this technology? So the enterprise container image, as well as all our images, are built on OpenJ9 and Sembro images, which come with a caching technology which is already integrated and enabled by default. Now, to leverage this capability, you simply need to include a specific step in your Docker file, that is run a configuration script, and that is actually available within the images and such. And this script is designed to prime all the caches effectively, optimizing the performance right from the start. Now, while this feature is enabled by default, we do have an option to disable it by setting the environment variable, that is OpenJ9 to false. And there could be valid reasons for doing so. Like, for example, if this caching process may add some extra time to your build steps, which could be a consideration in the environments where the rapid builds are kind of prioritized. And additionally, disabling it might be preferable if you want to minimize the overall size of your container image, as the caching process adds another layer that contributes to your image footprint. Now, ultimately, it's kind of important to weigh in all those factors about based on your specific use case and requirements. And by understanding the implications of enabling and disabling the shared class cache, you can kind of make the informed decisions about like what is best suited for your application performance and deployment needs. So this was all about the shared class cache which OpenLiberty offers to you. Now let's kind of move into like a small demo. Like I can show you like how the shared class cache is behaving as and such. So let me open my IDE. I do hope that my IDE is visible, right? Gautam, can you just confirm that for once?
Yes, it's visible.
Yeah, okay, thank you. So what I have over here is right. I have a simple Spring Boot project which is having Liberty in it, and I'm not going into deep into like what that Spring Boot project is doing because that's beyond the point right now. And the only thing which I want to focus right now is something which is the form.xml out here. And here we do have a plugin, and which is kind of a Liberty Maven plugin, and it kind of offers certain goals out there. And these goals are basically something like they can help you to download an instance of the Liberty instance out there, and then when you build it, and your application will be deployed in it. So if you see over here within the target, there is a Liberty folder which has the WLP, which is kind of a WebSphere Liberty profile, and within which your application is coming up. The other part which I want to focus on more is this kind of a Docker file. And this Docker file in this one, like it's a pretty much straightforward Docker file, like the one which we use to create the image and everything. The only part which I want to focus on right now is something called a OpenJ9 SEC, which I mentioned earlier. Like it is kind of a variable which we can like toggle around to enable the shared class cache or disable it. And for time being, like by default, it is enabled as true, and not just by this variable right now, which is displayed out here, but by in general, it is displayed like it is enabled as true. And I do have a VM argument defined out here, which I have kind of marked it as true because so that I can actually kind of control it when I'm passing the arguments while I'm building the image. Now, the another part which is like kind of important is this configure.sh script. So now this script is actually coming as part of the base image, and what it does basically is like when it gets executed, it is kind of starting your application multiple times and trying to understand like what are the classes which is getting loaded, and takes those class and stores in a memory or in a like a shared class cache out there. Okay, so that's the all about the Docker file and the pom.xml. Now let's see, let's try and create the build the image and everything. Okay, I'm actually in the boot liberty location, and I'm not good at commands, so I'm just copy pasting the commands which I have already pasted over here. Okay, so the first command I'm just creating, like I'm not passing what I'm doing is like I'm kind of setting it the value as false initially, so that it creates an image without using the shared class cache, and I'm naming it as a boot liberty. And okay, since it is in sudo, let me just give the password. Now what it will do is like it will build the image. Now the same thing, let me try with the one in which I have enabled the shared class cache. And if you can see, like the build name I've given, the image name I have given as like boot liberty SEC, and I have enabled it, like giving the value as true. And if I do this, okay, so the build is done. Now, one thing which you need to note here right now is like this build got completed really fast, and that is because that I already had executed the script previously, and that is the reason that most of the steps which are present over here are cached. It is taking from the memory. Okay, I'll just explain a bit on that part. Like if you're providing the SEC, that is the shared class cache, as a false value out here, what happens is that your script, that is this run configure script, it won't be getting executed, and it will be coming as 0 seconds, like what is being shown right now. But anyway, it is coming from the cache, that's why it is showing 0 seconds. But in real time, when you're building it for the first time also, it will come around 0 seconds for that one. But if you do enable it as true, this configure its script will take time to load. Like that will take some time. Like it might take probably I don't know like how much time it will take. I don't remember exactly how much time it takes, but it will take some time to build your complete image. And that is the point where I mentioned like your entire build process might get like the time for the build process might be increased a little bit when we have the shared class cache enabled. Okay, so one more point which I had mentioned earlier was the size of the image. Though, so if you go to the images out here, you can see the sizes, compare the sizes. So this is the one which we created without SCC shared class cache, and it has size around something around 1.5 gigs. And if we kind of enable the shared class cache, it is having 1.21 gigs. So we do see like that is actually kind of happening because there's an additional layer of cache which is present in between, which will help you to improve the startup times and all. So that was about the shared class cache. Now let's see like how it kinds of helps in improving the startup time. And let me go ahead and run the script, this command out here. Docker run. So I'm executing something in which I haven't yet enabled the shared class cache. And okay, so I think okay, it took something around 3.63 seconds to come up without shared class cache. Okay, now let's do one thing. Now let's just try to execute it. Sorry, uh, execute it with the one which is having a shared class cache enabled. And in this case, let's see. So the application is coming up in something around 1.89, 1.8 seconds. So what it means is like the startup time, I think it is approximately got reduced by 50% out here. So when you're kind of using the shared class cache, it is kind of helping you to reduce your startup time by taking or loading all the data from the caching mechanism out there. It do have a disadvantage of taking a little bit more time of like for building the image and a little bit more in size footprint over the image. But if you have tens or hundreds of microservices which are being deployed over there, and each time your application is getting started, the shared class cache is actually kind of giving you benefit over those trade-offs. So it is kind like we need to make a kind of an informed decision on like what we need and what we don't need. So that was about the shared class cache and yeah, about the open liberty and the open liberty which offers it. So there are many other benefits that open liberty offers, and I'll hand it over to Gautam to go through them. Over to you, Gautam.
Yeah, thanks, Alex. So
Yeah.
there are a lot of questions coming in the QA tab. If you can take a look, I answered few of them. I'm not sure you can see the comments I have put there, but if possible, you can check that and answer as well as far as possible because we may be having we may have some constraint answering. But,
Okay,
uh,
but I don't
meeting
like if I
itself.
can
Yeah.
switch the screen because since I'm presenting
Okay.
right now.
Okay.
So yeah.
Yeah. Sure. Sure. Okay. Yeah. Then I will move on. Like okay. So we'll start exploring the benefits of using OpenWrt. So the first one is about monolith to microservice. So this is based on architectural styles supported. Organizations frequently encounter a range of architectural needs driven by factors such as their size, organizational structure, team dynamics, frequency of updates, and requirements for agility. Selecting a runtime that provides robust and adaptable architectural support can significantly reduce the challenges associated with evolving Java applications demands and prevent the inconvenience of frequently switching between different runtimes, especially in this cloud native era. Liberty as a cloud native runtime excels in offering comprehensive architectural supports. Its modular design is a key strength, allowing it to effectively manage a broad spectrum of mission critical applications. So this versatility is evident in in its ability to handle diverse architectural styles, like from large scale enterprise level monolithic applications deployed on virtual machines to smaller, more agile microservices running in cloud environments. By supporting a wide range of use cases and deployment scenarios, Liberty ensures that organizations can maintain a consistent and efficient runtime environment as their needs evolve and grow. Next slide, please.
Yeah.
This is just enough runtime. Let's consider various architectural styles we mentioned earlier. So starting with a monolithic application. If we have a runtime size of around, say, 20 megabytes, 200 megabytes or something, achieve high availability in that model could increase the total footprint to approximately 600 megabytes, right? Next. Okay. So now if we transition to a microservices architecture where we have say 10, 10 microservices operating in a similar scaling manner, the total resource requirement could rise up to 6 GB. This is due to the additional overhead associated with managing multiple services while maintaining their individual functionalities. Further, if we shift a microservice architecture with 40 distinct services, each potentially scaled up to three times for performance and resilience, the cumulative resource usage could soar to around, say, 24 GB. This significant increase is attributed to the greater number of services, each requiring its own runtime environment and dependencies, leading to high overall resource consumption. If you can break your application to more and more fine-grained deployment unit, each one of them pulls down, say, its own copy of runtime, and there's a cost associated with that. And that's going to be very real cloud cost if you are deploying this into a cloud, but also very real on-prem infrastructure cost. As you transition from monolithic to microservices and further into microservices and functions, the resource requirements and the associated cost can escalate dramatically due to the increasing complexity and scaling needs inherent to each architectural style, right? So Liberty addresses these challenges with its lightweight and modular design. Liberty operates with a minimal core runtime, allowing you to configure and include only the specific capabilities required by each application. I can quote with an example. For instance, if you need to support microprofile, Liberty will dynamically load only the relevant components such as JAX service or RESTful services, microprofile configuration for configuration management, CDI, that is context and dependency injection, and others. So this means that each runtime instance will be precisely tailored to the needs of the application it supports. So that makes Liberty very lightweight. By adopting this approach, actually Liberty significantly reduces the overhead associated with each runtime instances. Each instance remains actually compact and agile, containing only the essential features needed to operate efficiently within itself. This modularity not only optimizes resource usage, but also helps in managing costs effectively, making Liberty a highly efficient choice for deploying microservices in a cost-effective manner. So, moving to the next important reason why we need Liberty, Alexia, it's low operating cost. The advent of cloud and serverless architecture has made it essential for applications to scale dynamically and swiftly in response to fluctuating workload demands. So during periods of low demand, applications can scale down to minimize operational cost in a process known as scale to zero. Conversely, when demand increases, such as when the volume of requests to a microservice rises, additional instances of the application and runtime must be provisioned quickly to maintain optimal responsiveness for end users. Uh, I hope everybody knowing that vertical and also on the scaling concept and everything. So consequently, the startup time of the runtime become a critical factor in both application performance and cost efficiency. To address this, actually in OpenLiberty includes a feature called Instant On, which leverages from we have our own IBM Semru JDK. So this Instant On actually leverages from IBM Semru Open JDK and Semru JDK and a Linux technology known as checkpoint restore in user space. So Instant On enables the runtime to create a checkpoint or a point in time snapshot of the application process. So this snapshot can be rapidly restored, allowing the application process to return to its previous state with minimal delay. So this capability significantly improves startup times and enhances efficiency of scaling uh, with that will result in operational efficiency, ensuring the applications remain responsive and cost effective even as demand fluctuates. So moving to the next slide. So here in the graph, you can see the performance results with and without Instant On. So Instant On improves startup time of Open Liberty application significantly by restoring the process from the checkpointed state. So this ping perf is a very simple ping type application involving a single rest endpoint And Rust CRUD is a bit more complicated and involves a JP and remote databases. And Acme microservice main that main uses the microprofile features. And with instant on feature, the startup time has been reduced by more than 90%. 90%. So, Alex, can we have a demo on this?
Yeah, sure. I'll do one thing. Let me let me go back to the command prompt first, and let me stop the this one. Okay, fine. You're seeing the command prompt, right?
Yes, we can see.
Yeah. Okay. So there are actually two options which are available to build an application container image that uses instant on. So one is to run a script which is called a checkpoint.sh script, which is at the end of your Docker file image, and but that option actually requires you to use the format. And there is another one more process, like another option, and that is that it actually involves a three-step process to build the application image, which could be used in Podman or in Docker. So I'll show this the second method in bit. The first step is actually like to create an application container image without the instant on layer. So we do already have a we already have an image created, that is a boot liberty -sec. So we'll make use of that C image. So that was the first step. The second step is actually kind of run that application container to take a checkpoint of the application in the running container. So let me go ahead and take the command. Okay, so what this command runs the application within a container and takes the application process checkpoint, and this env option actually sets a wlp checkpoint environment variable to specify the checkpoint after app startup option. So when the application process entire process completes, this container actually stops and get exited. Now, as a part of the third step, what we do is like we commit this stop container with the checkpoint process data into an instant on application container image. So let me go ahead and take that. Let me commit it. Okay, that's it. Now we no longer need this checkpoint container which we created initially, since we already have an image for that one. So let me just remove it as of time now. Yeah, so that's done. Now let's use this boot liberty instant on, since this is the image which we created, which already has the checkpointed data and everything. Let me start it. Just a sec. Okay, so we can see like the application is now coming with 0.835 seconds. So the point which I want to show is like the shared class cache and instant on are two different things. The with the shared class cache, so without the shared class cache, when the time was taking around 3.6 seconds, I remember, if I remember it correctly, and it got reduced to around 50% when we used the shared class cache, and it reduced to something around 1.5 seconds. And at a later point, when we are trying to make use of this instant on feature, it gets further reduced to something around 0.835 seconds. So basically, the instant on feature, which is available, is kind of helping you to reduce the startup time so that your applications or your instances which are running on the cloud environment can come up much more faster, so that it can cater all the requests which is coming. Like if large number of requests are coming out there, then they can cater it easily. So that was all about the instant on feature. I think this is what I can show right now. Over to you, Gautam. Back. Yeah. Hello, Gautam. You there?
Yeah. So, moving on to the next
Yeah.
topic, that is throughput. So, throughput is another crucial factor in reducing operational costs for your application. So, throughput measures the amount. So, those of you don't know what throughput is like, throughput measures the amount of work your application can handle with a given time frame. So, prioritizing and optimizing throughput can significantly impact your infrastructure expenses. Higher throughput means that your application can manage more requests or tasks with fewer instances, leading to reduced costs in both infrastructure and licensing. This is because many cores, including those associated with virtual CPUs, scale with the number of instances deployed. The relationship between throughput and cost is straightforward. The more efficiently your runtime can process tasks, the fewer instances you need to deploy the same workload. This efficiency translates into lower infrastructure costs and reduced licensing fees, which are often linked to virtual CPU usage. So the performance graph here illustrates that OpenLiberty offers notable throughput advantage compared to other runtimes. Moving on to the next slide. So when evaluating throughput performance, comparing Springboot running on OpenLiberty to Springboot running on Tomcat reveals a significant advantage. So I see a lot of questions in the Q&A chat chat box regarding this kind of situations. Like uh, so here the graph demonstrates that OpenLiberty provides nearly twice the throughput of Tomcat. This substantial improvement in throughput is consistent with findings from previous comparisons with Tomcat, indicating that OpenLiberty consistently delivers approximately twice the throughput of frontends based on Tomcat. Moving on to the next. So another key factor contributing to lower operating cost of Liberty is its efficient memory usage. So in cloud services, there is a well-established relationship between memory consumption and cost. For example, in Azure Kubernetes service, if the memory requirements of nodes are double, the cost also double. Additionally, the pricing model often links memory usage of CPU allocation, which can further affect licensing expenses. So here in the graph, comparing memory footprints across different runtimes clearly illustrates this point. A lower memory footprint indicates more efficient memory utilization. According to the data, OpenLiberty demonstrates a significant advantage using between 1.3 and 2.9 less memory compared to other runtimes. So this efficiency not only helps in reducing infrastructure costs, but also potentially lowers licensing fees, as less memory typically translates to reduced overall expenses. So moving to the next. So have if you are using Spring Boot for your application, then it is observed that running on OpenLiberty has an approximately 2x memory footprint benefit when compared with Tomcat. So here you can see in the graph. This was all about low operating cost of Liberty. Now let's have a look on the next reason why we need Liberty. Moving on to the next. So that is continuous delivery. If you can go to the next slide.
Yeah.
So here you can, I'm not going to explain everything in this slide. So it's about continuous delivery. So Open Liberty's mission is to support development teams in maintaining the security integrity of the deployed application while minimizing technical debt. So Liberty operates on a continuous delivery model with new releases every 4 weeks. So here are the release statistics from the past few years. So you can see here in the flowchart and in the table itself. So moving on to the next reason why we need Liberty. So that is zero migration. So one of the most significant advantages of Liberty is its zero migration policy. This also I saw a lot of questions in the chat. So is there any specific configuration change that we need to Liberty if we switch from Tomcat to Liberty? So one of the most significant advantages of Liberty is, as I said, the zero migration, which stands out as a major highlight here. So typically, migrating to the latest version of a technology that your application relies on involves extensive code and configuration changes, right? So this is often necessary for enhanced security or to take advantage of new features. But It can require months of meticulous planning and a considerable investment of time, developer time, etc. So Liberty simplifies this process through its zero migration policy. So this policy established clear guidelines for updating Liberty, ensuring that if there are no changes to a server configuration, the runtime behavior remains consistent. Especially, Liberty does not alter the behavior of its features or remove any capabilities that your application relies on. While you may receive security updates, these updates will not impact existing behavior of your features. So this approach means that you can benefit from the latest improvements and updates with minimal effort, often just by repacking your application without undergoing complex and time-consuming migration process typically associated with technology upgrades. So, moving to the next reason why we need Liberty. So that is cloud optimized. So we are living in the cloud era. So this is a very important point. In a cloud environment, the cost of running applications influenced by several factors. So we were discussing about the several factors from the initial discussion like the size of the application on the disk, its memory consumption, and CPU usage, etc., etc. So these elements collectively determine the operational expenses of your business. So when working with a microservices architecture, where you may deploy tens or even hundreds of individual microservices, each requiring its own runtime instance, achieving efficiency becomes even more critical. So each microservices footprints impact overall cost. So it's essential to ensure that these microservices are as resource efficient as possible. This efficiency reduces the amount of memory and CPU resources needed, which can significantly lower your cloud infrastructure costs. So even if your infrastructure is in microservices based and you are working with traditional monolithic applications, having a smaller footprint means beneficial. That remains beneficial. So if you want to deploy it in the cloud, so a reduced memory and CPU usage translates to lower cost and better performance, regardless of your architectural style, whether it's mono, microservice, etc. So our previous comparison of memory usage and throughput and in various runtimes clearly illustrates that Liberty excels in this regard. So by leveraging Liberty, you benefit from its cloud optimized design, which minimizes resource consumption and maximizes efficiency. This makes Liberty an excellent choice for both microservices and other application architectures, helping to keep operational costs down by delivering robust performance. So moving on to the last one, that is developer experience. If you can go to the next slide. So one of Liberty's core goals has been to significantly boost developer productivity, a focus that has been at the forefront of its development and enhancement over the past decade. So developers are actually developing the application. So developer experience of using Liberty, that is very important. So by prioritizing features that reduce complexity, automate routine tasks, and support modern development practices, Liberty aims to help developers work more efficiently and effectively. So this ongoing dedication to enhancing the developer experience ensures that Liberty remains a powerful tool for creating and managing applications with greater ease and agility for the developers who are using them. So with that, we are winding up. Yeah, that's it. Thank you.
Thanks, everyone. I'll just stop my sharing for time being. Okay.
So I don't know how to answer these questions, how to prioritize. There are a lot of questions in the chat. I have answered few of them.
All right, so
Okay.
let's start with the first questions. Okay, so we have here from our anonymous attendees, what are the most significant advantages and disadvantages of running Spring Boot applications in Liberty compared to other popular application servers like Tomcat?
So I think we already covered that as part of our session, like when we defined like showed out the graph, like the memory advantages, the memory footprint advantages, the throughput advantages, all those kind of stuff. So that's, I think, already got answered as part of the session itself.
All right. So moving on to the next questions from Chris. Can we create a non-web application in Spring Boot?
Uh, non-web applications, can you, who's that?
Chris, right?
Okay, Chris. So, Chris, can you tell us what is your use case, like in a non-web application, what you are going to achieve? Like,
All right. Thank you for that. And for the last question from Miss Colleen. What advantages does Spring Boot offer compared to other similar frameworks?
Yeah, actually, the Spring Boot has a lot of functionalities within it. Like it does offer, like as I mentioned in the initial introduction part, like it does offers a lot of, uh, like it helps to remove a lot of boilerplate codes which we have out there. So a lot of configurations and everything, those are coming as part of the properties itself. So we don't need to worry about like configuring them up properly. Most of the time, we just need to add an annotation, and we have our application out there. So I think that is what one of the biggest like advantage of the using the Spring Boot.
All right. So thank you, our dear speakers, for answering the questions. Now, for those who has a question, please feel free to chat with our speaker on our meet. And that's all the time we have for this session. If you enjoyed this session, please give your rating and share your feedback about our speaker. You'll find the link in the chat box. So again, let's thank our speakers by clicking on the heart or clapping emojis. So thank you, guys. Please exit this session and click on to the next. Bye.
Bye. Thank you.
thank you
Thanks
so
a lot.
much. Bye.
Thank you.
Bye.